When you visit a website, your browser has to figure out where to connect and which protocols the server supports. Traditionally, that meant multiple round trips. Look up an address, try to connect, discover the server's capabilities, and sometimes retry when the first attempt fails. What if DNS could hand your client everything it needs before a single connection is made? DNSimple supports service binding and HTTPS records, which help a client connect faster by skipping the back and forth negotiation that typically happens. Service binding attaches connection details such as which protocols and ports a service supports directly to a DNS name. When your client looks up that name, it gets not just an address, but the information it needs to connect efficiently without extra discovery steps. Service binding and HTTPS records are what make service binding possible. What are service binding records? Service binding records are a pair of DNS record types that give clients the information they need to connect to a service before they establish a connection. They're defined in RFC 9460, and they come in two forms. Service binding or SVCB records are a general purpose record that can describe any kind of service by showing the name and protocol in the domain name. HTTPS records are the same idea, but specialized for HTTP and HTTPS. Because the service and protocol are implied, you use a simpler name, just the host name like example.com with no extra prefix. Under the hood, both record types share the same structure and behavior, with the main difference being how you name them. Why do service binding records matter? Service binding records improve performance by eliminating DNS queries and server-client communications. Typically, your browser would need to query A and Quad A records, then do the TCP and TLS handshakes, and on top of that, if the server supports HTTP 3, it would try again with another protocol called QUIC. With service binding records, the client gets the IP and protocols in one DNS query and can go straight into connecting to the server. With fewer round trips and attempts, service binding records both speed up the connection process and limit how much of the connection behavior is exposed. Lastly, Apex aliasing is a major benefit that was previously impossible with CNAME records. Service binding records in AliasMode allow you to have your root domain point to another hostname, such as a content delivery network or a hosting service. How do service binding and HTTPS records work? Every service binding and HTTPS record has three main parts: the priority, target, and service parameters. The priority is a number from 0 to 2 to the 16th. A lower value takes precedence over higher ones, similar to how MX records work. This number also determines the record's mode. When the priority is 0, the record is in alias mode, where it behaves like a CNAME record, pointing to another hostname where the client should follow to. The advantage of service binding records is that they can be used to alias the Apex domain. CNAME records cannot exist at the Apex, so service binding records solve a long-standing limitation for anyone who wants to alias their root domain to another hostname. When the priority is greater than 0, the record is in service mode. Here, the record doesn't just redirect, but describes an endpoint and optional parameters. When multiple records are published with different priorities, they offer alternative fallback endpoints, and clients try lower priorities first when resolving. The target is always a host name. In alias mode, it's the alias target, and in service mode, it's the endpoint that provides the service. The service parameters are optional key value pairs that add configuration. For HTTPS records, common parameters advertise HTTP 2 and 3 support, as well as the port number. Some other common parameters include hints for IPv4 and IPv6 addresses and the encrypted hello used by TLS. Here are two examples of what an HTTPS record looks like when queried. Alias mode is signified by a 0 in the priority, so here the record is acting as an alias from example.com to example.net. This second one shows a priority of 1, so it is in service mode, and says that the domain supports both HTTP 2 and 3, and the port for the HTTPS service is 443. In contrast, Service binding records aren't limited to HTTPS, so their name must include the service and protocol in this form. In this example, the service binding record is in ServiceMode and shows that a protocol example over TCP supports HTTP2 and the port number is 521. The IPv4 hint tells the client what address the server is at, so a separate A record query is squipped, reducing latency even further. Managing service binding and HTTPS records in DNSimple can be accomplished with the same tooling that you use for our other record types. Whether you use the web interface, API, or Terraform provider, you can manage service binding records in a way that fits your workflow. With the freedom of our sandbox environment, you can make sure your integrations are working properly before deploying to production. Service binding and HTTPS records can help shave off lots of latency time, so making sure your configuration is correct first is critical. Use TLSA records in conjunction with service binding records to secure your domain while broadcasting that your domain supports TLS. The service binding record parameters can even save a step for the handshake by providing the ECH public keys for TLS. Want to give DNSimple a try risk-free? Visit dnsimple.com/signup. Need more information about how DNS works with DNSimple? Check out other videos on our channel and read our comic linked in the description. For more information about how TLSA records work, watch this video next.